we're going to look at how to verify inverse functions, right? So we have to talk about what an inverse function is and then how we can go about verifying and making sure a given pair of functions are inverses. So that's really all we're looking at in terms of learning outcomes, is verifying them. So what is an inverse function? We've got, for a function f of x, the inverse, just as a notational thing, is written this way, right? So let's consider these two functions that we've got here. 1 over x plus 1 and 1 over x minus 1. Okay, first question is, what is f of g of 2, right? So g of 2 is 1 over 2 minus 1. Okay, so f of g of 2 is really f of negative 1/2, which is 1 over negative 1/2 plus 1, right? We start by plugging 2 into g, so 1 over 2 minus 1. That's where this is coming from. That simplifies to be negative 1/2, and then we're doing f of negative 1/2, plugging negative 1/2 in right there. So that is 1 over 1/2, which is 2. So the thing to note here is that f of g of 2 is 2. That's going to be the theme with inverses. So here, what about f of g of x? So we're talking about taking this and plugging it in right there. So how is that going to look? It's going to be 1 over x minus 1 plus 1, right? We're just replacing this x with this entire expression, 1 over x minus 1. Then we want to simplify it. So the denominator, 1 over x minus 1 plus 1, the minus 1 plus 1's cancel. We've got 1 over x, which is just x. So again, on the last page, we plugged in 2, we get out 2. Here, we plug in x, we get out x. Okay, so that theme continues. And then what if we flip it around? Right, last page we did f of g of x, now we're doing g of f of x. So we're going to plug this entire expression in right there. So that would be, what, 1 over x plus 1 minus 1. So 1 over x plus 1 is just x plus 1 minus 1 is x. So again, that theme continues there and there. So inverse functions basically undo each other, right? So if we did that first example, we plugged in 2 to g, then into f, we got 2 back out. Then we plug x into g, that result into f, got x back out, and then here we plugged x into f, plugged that result into g, we got x back out. So that whole process verified for us that g of x is f inverse, right? We've verified that. So, based on what we saw with those examples and that discussion of an inverse function and inverses, what would be the inverse of f of x equals x squared? Right? You want to undo that x squared. You might want to say that like f inverse is the square root of x. Right? If I plug 2 in here, I do 2 squared is 4. And if I plug that result in here, square root of 4 is 2. I got what I started with. So in this case, I could say that's the inverse, and is that inverse a function? Yes. That is in fact a radical function. Right, just because if you don't remember, that symbol is not a square root symbol, it's a radical. And so this is a radical function. Similarly down here, the inverse of g could be the instead of the square root of x, the cubed root of x, right? And that is also a radical function. Okay, so that's all that an inverse means. It's undoing whatever the function did. So then how are we going to verify these things, right? Again, if we want to make the notation a little bit easier, we could, instead of calling this f inverse, we could say g. We want to do f of g of x, and we also want to do g of f of x. You have to do both, okay? Both directions have to work, and the result that you want is that it should equal x both times. So f of g would be 3x minus 5 plus 5 over 3. Right, the minus 5 plus 5 cancels, so we have 3x over 3, which is x. Huzzah, that one works. How about g of f? That's 3 times x plus 5 over 3 minus 5. The 3's cancel, we've got x plus 5 minus 5, which is x. Huzzah. We, at that point, have verified that these two are inverses. We did f of g of x, saw that it simplified to x. We did g of f of x, saw that it simplified to x. That's all we need to do. That verifies that these two things are in fact inverses. So it's the same deal here. Here I'll stick with this notation of f inverse, just because we can. So f of f inverse would be the square root of 2 times x squared plus 5 over 2 minus 5. So that's going to be the square root of x squared plus 5 minus 5, which is the square root of x squared, which we can just say is x. Okay, really should be the absolute value of x, but it's x. Okay, then how about f inverse of f of x? Right, so f inverse of f of x is going to be the square root of 2x minus 5 squared plus 5 over 2. You square the square root, we've got 2x minus 5 plus 5 over 2 is just 2x over 2, which is just x. So we got it here, and we got it here. Okay? Again, that's all it really means to verify. We will have to talk about, at some point, the fact that this really should be absolute value, and so the implications of what that means in terms of inverses and whether or not inverses are functions. But for now, this process of verifying is all we really need. Okay? So that's all you should be comfortable with at this point, is how to verify that two given functions are inverses.